Hello everyone. In this lecture, we are going to study the important concept related with the chapter trigonometric function. And in that, our concept is here inverse trigonometric functions. Inverse trigonometric functions. Okay, in this subtopic, we have to define the inverse of given trigonometric functions. And for this, here we know here if f is the given function and it's from here a to b, then we define inverse of given function and we use the notation for this here f inverse. Here f inverse is the notation for the inverse of the function f, and we define this by using here mapping from b to a. Okay, here we define f inverse from here mapping from b to a only if your given function f is 1, 1 and onto. We know this concept. Now in this lecture we are going to study the trigonometric functions and its inverse. Here we know trigonometric ratios defines the trigonometric functions and inverse of the given trigonometric function. Okay, for the inverse of given trigonometric functions we consider the given trigonometric functions. Okay, now here we know trigonometric functions are periodic. Trigonometric functions are periodic and repeat their values after each interval. So in another interval, in some intervals trigonometric functions have the same values. Hence we restrict their domains to the suitable intervals so that this domain is 1, 1 and onto. Okay, and here range is also 1, 1 and onto. So we can have their inverses. Here remember, if f is a 1, 1 and onto function, then the inverse of given function exists. Okay, let's go with our first trigonometric function. Okay, and here we consider inverse function of sine. Inverse function of sine. Okay, here we consider one function. Consider here sine function. And here having the domain, here domain is close interval minus pi by 2 to pi by 2 to the close interval minus 1 to 1. Here domain for sine is close interval minus pi by 2 to pi by 2 and range for the given sine is a minus close interval minus 1 to 1. By considering this domain and range, here we consider given function is a 1, 1 and onto. If the given function is 1, 1 and onto, here inverse of trigonometric function sine exists. Inverse of trigonometric function sine exists, and we denote this by using here sine inverse. And here sine inverse is a mapping which is from close interval minus 1 to 1 to here close interval minus pi by 2 to pi by 2. Close interval minus pi by 2 to pi by 2. Here remember, if sine theta is equal to x, then here I write theta separately as here theta is equal to sine inverse of x. And here this theta is the principal value. Here theta is the principal value. We consider the principal value. And here the principal value branch for the given inverse function, that is for sine inverse, is close interval minus pi by 2 to pi by 2. Here I write here principal value branch for sine inverse is here close interval minus pi by 2 to pi by 2. So remember this point. Let's go with our next trigonometric function, and is cosine. Here we consider inverse function of cosine. Inverse function of cosine. Inverse function of cosine. Here again we consider here cos maps from here close interval 0 to pi to the close interval minus 1 to 1. Here domain for the given trigonometric function is close interval 0 to pi, and here range for given function is minus 1 to 1. And by considering the domain and range for the given trigonometric function, here we say here it is 1 1 and onto. If the given function cos is 1 1 and onto, here inverse of trigonometric function cosine exists, and we denote this by using here cos inverse, and is the function which is from close interval minus 1 to 1 to close interval 0 to pi. Now here remember, if here cos theta is equal to x, then here I write theta separately as cos inverse of x, and here this theta is the principal value. Here theta is principal value, and principal value branch for the cos inverse is close interval 0 to pi. Also principal value branch for cos inverse is here close interval 0 to pi. Remember this. Okay, then we go with our next trigonometric function, and is tangent. Okay, let's go with third point. Here in third we consider inverse function of tangent. Inverse function of tangent. Okay. Similarly, here we consider the tan function. Okay, here tan is, we define the function tan, and which is from, here this is from open interval minus pi by 2 to pi by 2 to r. Remember, here domain for the given function is open interval minus pi by 2 to pi by 2, and range for the given function is r. Okay, by considering the domain and range of the given trigonometric function tan, here we say it is 1 1 and onto. If it is 1 1 and onto, here we say inverse of given trigonometric function tan exists, and this inverse function is denoted by using here tan inverse, and is the function which is from r to open interval minus pi by 2 to pi by 2. Open interval minus pi by 2 to pi by 2. Now here we consider tan theta is equal to x. If tan theta is equal to x, then we say here theta is equal to tan inverse of x, and here this theta is called principal value of the given function tangent, given trigonometric function tan. Okay, here I write here theta is the principal value, and here the principal value branch is for trigonometric function tan inverse is here open interval minus pi by 2 to pi by 2. Open interval minus pi by 2 to pi by 2. Okay, so this is for inverse function of tangent. Now we go with our next trigonometric function and is cotangent. Okay, so here we consider in fourth point inverse function of cotangent. Here again we consider cot is function which is from open interval 0 to pi to r. Here domain for, we know domain for this cotangent is open interval 0 to pi, and range for the given function is r. Okay, now here by considering the domain and range of the given trigonometric function, here we say it is 1 1 and onto. If it is 1 1 and onto, here inverse function of cotangent exists, and we denote inverse function of cotangent by using here cot inverse, and is the function. This is the function which is from r to open interval 0 to pi. R to open interval 0 to pi. Now here we consider if cot theta is equal to x, then here theta is equal to cot inverse of x. Theta is equal to cot inverse of x. Here this theta is the principal value, and the principal value branch, for the given function is here open interval 0 to pi. Here is open interval 0 to pi. Okay, so this is for the inverse function of cotangent. Let's go with our fifth point. In that we consider inverse function of secant. Okay, so here in fifth we consider inverse function of secant. Okay, so here again we consider the function sec. Okay, here sec is the function which is from here close interval 0 to pi by close interval 0 to pi minus here we consider pi by 2. Okay, except the value of pi by 2. We consider all the elements in between this close interval 0 to pi. Here everyone knows sec pi by 2 is not defined. Since sec pi by 2 is not defined, here we accept the value pi by 2. Okay, we accept the value this pi by 2. So this is the function which is from close interval 0 to pi minus this pi by 2 to here we consider r minus close interval minus 1 to 1. Here domain for the given trigonometric function is close interval 0 to pi minus pi by 2, and the range for the given function is here r minus of close interval minus 1 to 1. By considering the domain and range of the given function, here we say it is 1 1 and onto. If it is 1 1 and onto, here inverse of the function secant exists. Inverse of the function sec exists, and we denote this by using here sec inverse, and is the function which is from r minus close interval minus 1 to 1 to the close interval 0 to pi except the value pi by 2. Except the value pi by 2. Now here we consider sec theta is equal to x. Sec theta is equal to x. Then here we get theta as here theta is equal to sec inverse of x. Theta is sec inverse of x. Okay, here theta is called the principal value. Theta is called the principal value, and principal value branch for the given function is here close interval 0 to pi except the value pi by 2. Except the value pi by 2. So remember this principal value branch. Okay, let's go with our last trigonometric function. In that we consider cosecant. Okay, so here in 6th point we consider inverse function of cosecant. Okay, and here to define the inverse of the function cosecant, we consider cosec is the function here. This is from close interval minus pi by 2 to pi by 2 except the value 0. Except the value 0 to here r minus close interval minus 1 to 1. Now here we accept the value 0, since here cosec 0 is not defined. Here cosec 0 is not defined. Okay, so remember this point. Now here by considering the domain and range of the given trigonometric function cosec, here we say it is a 1 1 and onto. Okay, here it is 1 1 and onto. If it is 1 1 and onto, here inverse of given function cosec exists. If it is exists, here we define cosec inverse, and is the function which is from r minus close interval minus 1 to 1 to close interval minus pi by 2 to pi by 2 except the value 0. Except the value 0. Okay, now here we consider cosec theta is equal to x. If cosec theta is equal to x, we say here theta is equal to cosec inverse of x. Okay, and here this theta, here theta is called principal value. It's called principal value and principal value branch. Principal value branch for given trigonometric function is here close interval minus pi by 2 to pi by 2 except the value 0. Except the value 0. So remember, this principal value branch for the inverse function cosecant and is closed interval minus pi by 2 to pi by 2 except the value 0. Okay, so here we define all the inverse trigonometric function. Here we define domain and range for the inverse trigonometric functions and the principal value branch for the each function. Let us consider some examples depending on these inverse trigonometric functions. Okay, so here in example we consider find the principal value of the following. Find the principal value of the following. Let's go with first one. Here in first, given sine inverse of 1 upon 2. Sine inverse of 1 upon 2. We have to find the principal value which lies in between the principal value branch. I repeat again, here we have to find the principal value which lies in between the principal value branch. Okay, so to find the value, we consider the sine inverse of 1 upon 2 is equal to x. Now by using our definition of inverse trigonometric function, here I write this as sine x is equal to 1 upon 2. We get sine x is equal to 1 upon 2. Okay, then here I write this as sine x is equal to. Now here we know sine 30 degree, that is sine pi by 6 is here 1 upon 2. Sine pi by 6 is 1 upon 2. So here sine x is equal to 1 upon 2 is equal to sine of pi by 6. Okay, by comparing first with last, here we get x is equal to pi by 6. Now we have to check whether this x lies in between principal value branch or not. Now here everyone knows the principal value branch for sine inverse. We know principal value branch for sine inverse is closed interval minus pi by 2 to pi by 2. And here this belongs to closed interval minus pi by 2 to pi by 2. If it is lies in between this principal value branch, here principal value is x is equal to pi by 6. Therefore, the principal value is here pi by 6. Okay, let's go with second one. Let's go with our second example. In second, we consider cosec inverse of 2. Cosec inverse of 2. Again, we have to find the principal value which lies in between the principal value branch. Okay, so we consider here cosec inverse of 2 is equal to x. Then by using our definition of inverse trigonometric function, here I write this as cosec x is equal to 2. Therefore, here I write this as cosec x is equal to 2 and is equal to. We know here cosec x is 1 upon sine x. Okay, and we know sine pi by 6 is 1 upon 2. Sine pi by 6 is 1 upon 2. So here cosec x is equal to 2 is also here cosec pi by 6. Is cosec pi by 6. By considering this first and last, here we get x is equal to pi by 6. Now we consider the principal value branch. Here principal value branch for the given trigonometric function cosec inverse is here close interval minus pi by 2 to pi by 2 except the value 0. Except the value 0. Okay, and this pi by 6 is lies in our interval. Okay, so this belongs to your close interval minus pi by 2 to pi by 2. Okay, therefore here principal value, the principal value is pi by 6. Principal value is pi by 6. Okay, now we go with our third example. Let's go with our third example. In third, we consider tan inverse of x. Tan inverse of minus 1 is equal to tan inverse of minus 1. Let us consider this tan inverse of minus 1 as x. Consider tan inverse of minus 1 is equal to x. Then by using our definition of inverse trigonometric function, here I write this as tan x is equal to minus 1. Then here I write this tan x as is equal to minus sign as it is, and everyone knows here tan pi by 4 is 1. So here minus tan pi by 4. Minus tan pi by 4. Okay, then here I write this as tan x is equal to, here I write this tan x as tan of minus pi by 4. Since everyone knows here tan of minus x, here tan of minus x is minus tan x, is minus tan x. Now comparing these two, here we get x is equal to minus pi by 4, is minus pi by 4. And everyone knows here this belongs to the open interval minus pi by 2 to pi by 2. This minus pi by 4 lies in this interval. If it is lies in this interval, here I write, therefore the principal value is, minus pi by 4, is minus pi by 4. So in today's lecture, we define the inverse trigonometric functions. We define sine inverse, cos inverse, tan inverse, then cot inverse, sec inverse and cosec inverse. We see domain and range for the given inverse trigonometric functions. We also define the principal value branch for each function. And we see 3 important examples related with this concept. Thank you.